Okay, so we just finished number 6, and we are starting number 7. Okay, so for number 7, we have this question: what is the following product? I don't see any product here. I am going to assume this is the product we're talking about, this square root of 12 plus square root of 6 times square root of 6 minus square root of 10. So I'm going to assume this is the product and go about it this way. So we have to use FOIL, and whenever we use FOIL, just as a rundown, if we have any a plus b times any c plus d, we want to multiply first inner, so we want to go a times c plus a times d plus b times c plus b times d. And that's basically how a FOIL of terms with sum of two terms, the product of the sum of two terms, is carried out. So with that being said, let's carry this out on our problem here. So we're going to have the square root of 12 plus the square root of 6. And another thing to note, that whenever we have the square root of a times the square root of b, we can actually bring them inside of the square root as so. So we have the square root of ab. And that's what we're going to do for all these products. So we're going to have the square root of 12 times the square root of 6. I'm going to write them out separately initially. So that's the first one, and then minus the square root of 12 times the square root of 10, and then plus the square root of 6 times the square root of 6 right here, and then plus the square root of 6 times the square root of 10. And now by just bringing them in together as products inside of their respective square roots, we're going to have the square root of 72 minus the square root of 120 plus the square root of 36 plus the square root of 60. Now, in order to actually begin to evaluate these and see if we can combine anything, we have to simplify these radicals. So the way it works is we're going to factorize them, we're going to prime factorize them, and see if we can get them as the product of two square roots where one of them is a perfect square. So just off the top of my head, I know that 4 goes in, I know that 9 goes into 72. So that could be written as the square root of 9 times the square root of 8. Another thing is I can possibly see this being written as the square root of 4 times the square root of 30. And then square root of 36 is easy because it's a perfect square. So we're going to have 6. And once again, I can see the square root of 60 being written as the square root of 4 times the square root of 15. So after this first step here, we're going to get, so the square root of 9 simplifies to 3, square root of 8, and just to save another step, let's see if the square root of 8 can be simplified further. I know it can be. It could be broken up into the square root of 4 times the square root of 2, where 4 is our perfect square. And then we're going to get minus 2, and looking at this square root of 30, there's not much we can do with it to actually decompose it because none of its factors are perfect squares. So then plus 6 plus square root of 4 is 2 square root of 15. So after this final step here where we just evaluate the square root of 4 and multiply it to 3, we're going to get 3 times 2, which is 6, root 2 minus 2 root 30 plus 6 plus 2 root 15. And this is our answer right here. And it is said exactly the same way here. So option A, if that is what option A is, that is correct. So this is the correct solution. Great job. And got an extra space here. Okay. And that would be correct in this case. So time for the next question.